Tidal power, a sustainable energy solution. Tidal power is a form of renewable energy that harnesses the kinetic motion of the ocean tides and converts it into usable electrical energy. Tidal power is renewable, sustainable, reliable, and predictable. This form of energy tends to be much more reliable than other types of renewables, such as solar or wind power. This is due to the predictability of ocean tides. Tidal power can be generated using 3 different techniques known as tidal barrages, tidal fences, and tidal turbines. Barrages, much like the first tidal mill, create energy by capturing water behind a sluice gate when the tide comes up and releasing it through a turbine or water wheel after the tide has receded. The flow of water through the wheel or turbine is what generates the electricity by spinning these gears which are attached to a generator. These barrages are similar to dams and hydroelectric plants, except on a much longer scale. These structures are usually built across an estuary or bay and need approximately 5 meters of tidal differential in order to operate properly. The other techniques to capture tidal energy are tidal fences and tidal turbines. Tidal fences operate like giant turnstiles, while tidal turbines resemble wind turbines, but underwater. Both of these techniques generate electricity when the energy of the tidal currents turn the turbine. The positive aspect gained by making these turbines underwater is that water is 832 times denser than air, and therefore will apply a greater force on the turbine and generate more energy. As a consequence of the density differentials, tidal turbines are able to be built much closer together than wind turbines and also require much smaller blades. The estimation of tidal power potential can be represented by the power equation, which is determined using the density of water, gravitational acceleration, area of the bay, tidal amplitude, and the radial frequency of tidal oscillation. Tidal power potential also varies based on region. This data shows that Alaska tends to have significantly more tidal resources than other areas around the world, making it an excellent location for the implementation of this form of renewable energy. The triple bottom line includes environmental, economic, and social factors. Environmentally, the energy production itself does not emit pollutions or greenhouse gases. It does, however, emit gases during the installation process. One concern is that tidal turbines can potentially have a negative effect on marine and shoreline ecosystems. These effects depend on the geographic location of the system and the types of wildlife in the area. Economically, tidal power's cost effectiveness is determined by the difference in height between high and low tide. The initial setup of tidal systems are very high with a long installation period, but this is outweighed by the low operation costs. Positive social effect is that these tidal plants could create many operation jobs as well as construction jobs throughout their installation and lifetime. It could also be an information center which would create tourism positions and educational opportunities. Tidal power is an acceptable form of renewable energy based on environmental, economic, and social considerations. This form of renewable energy is both reliable and predictable due to the constant moving of the tides. Tidal energy has huge potential and should be used more throughout the world in order to transition away from non-renewable energies and lead to a more sustainable future.